Hello guys, uh, I am Rashanji, your chemistry teacher. Um, so, so due to the lockdown and the emergencies due to the spreading of the COVID-19, so it is well advised to stay in your home and obviously you have to study. So today, the topic I will going to talk about is part of class 12 chemistry curriculum, and it is one of the very important topics, important topic counted in terms of your macroscopic states of an element. Now, first question here is what are the macroscopic states? Hmm? We have we have solid, we have liquid, and we have gas. Hmm? You have already learned about gaseous state in your class 11. Hmm. And I would give advise you guys that before reading this chapter, this solid state in of class 12, you just go back, just open your NCRT book, and NCRT class 11 book, and just read the first part of the chapter states of matter, where they have discussed different states of matter and different properties of solids, liquids, and gases. And the most important thing is the intermolecular interaction force versus the thermal energy. Okay, so beginning with the topic solid state, solid state. Okay, solid state. The topic which I'm going to cover in few lectures. Okay, and I have also given the your lecture as a module, and which is I have in my hand, which is documents I have in my hand, and also I have provided one assignment sheet. Okay, and for different modules, as I will give, so I will provide different uh, different assignments. Okay, so you guys just go through the assignments and solve those problems. You have to encounter many theoretical problems. You have to write the explanations. You can encounter short questions, MCQ types. Okay, maybe fill in the blanks types, or you can, or in this part especially you will encounter numerical types. Okay, so just go through everything, and your if you have any book, just go through them also, and then follow the assignments. I think you will get a pretty good idea about this chapter. Okay. So starting with the solid state, if I see the comparison, just briefly I will discuss the comparison here. Let's say in solid you have the molecules are arranged in a ordered fashion, right? In an ordered fashion. Okay. But in case of liquid, the orderness decreases and the intermolecular gaps increases and the intermolecular attraction force between the molecules decreases. So this is a liquid state. Okay. This is a solid state. And further, if you see, okay, further, okay, the molecules are more far apart. Okay, so this is a gaseous state. Gaseous state. So three distinct states are you can see in any element you have. Hmm? Okay. Now these three states is function of temperature, definitely function of temperature. Why? Because the molecule has a kinetic energy, and the kinetic energy is nothing but the function of temperature. Now, if you increase the temperature, the kinetic energy of the molecule increases, and as a result, what happens? It overcomes the intermolecular attraction force and results the changing of the state. Okay. Acha. Now, but here, this liquid state and gaseous state I will not discuss, because gaseous state you have already learned in your class 11. Okay, and liquid state I will discuss in class 12 briefly before in your next chapter, which is solution. Okay, before that. So let's move on to the solids. Now, when I say solids, that means it will have a perfect shape and size, definitely. But there are few solids exist in this universe, those does not have any shape and size, but they are solid in nature. Okay, I would say elastic is a good example. Okay, like plastic. How will you classify plastic? Plastic is a polymer or polyethylene. Okay, but it is a solid in nature. It's not a gaseous in nature, right? It's solid in nature. But that is also one type of solid, but it is elastic in nature. But by principle, the solid should not elongate, or it should be a rigid one. Okay. So based on this phenomenon, okay, this thing, okay, a solid can be classified into two parts. Okay. Number one is crystalline, crystalline, and number two is amorphous. Amorphous, Phous. Amorphous. Okay, I should write this in block. Hmm. Okay, so crystalline and amorphous. Okay, now these two states, these two cases, crystalline case and amorphous case, they have a very distinct behavior and a very distinct physical characteristics. Okay, Acha. So, and in that module, I have details. In details, I have given their details description. But I will here discuss few important points that you guys need to understand very clearly. Number one, in case of crystalline substances, okay, better I would write it this way. Okay. So, solid state, we define into two parts, crystalline and amorphous. Okay, that's it. So, number one, what I can write in the crystalline state, when I say crystal, okay, definitely you will pop in your head diamond, right? Diamond, ice. Okay. So what they have? They have a definite shape and size. Okay. And which they don't have. They don't have a definite shape and size. Mostly they are irregular. Irregular, right? Okay. Irregular. Like, okay. Like it can be happen this way. It can happen this way. Sorry, this way. Okay. Any of the shapes they can happen. Irregular kind of. Okay. Number two. Okay. Acha, melting point, which is a very important thing, melting point. Now, when I say melting point, okay, one thing will occur in your head is that I'm giving a temperature and that solid body melts to liquid. Now, let's say now when I compare with respect to this point, this point and this point, let's say if you have a this kind of arrangement, let's say, okay, this kind of, so this is a crystalline arrangement, regular regular repetitive unit pattern, and this is a amorphous kind of arrangement. Okay, now when I give heat temperature in both of cases, what will happen? This will also melt, this will also melt. Hmm? Now if you see here, when I when a solid body melts, this is very important, clearly listen very carefully. When a solid body melts, okay, then it will melt by one molecule, one molecule, one molecule, molecular gap, then okay, molecular gap, then another molecular gap. So basically, when I say regular shape, that means the molecular gap is same in all the cases. But when I say irregular shape, the molecular gaps are different. In some cases, maybe they are close. In some cases, they are far. Okay, but in case of solid, in case of crystalline, all the molecular gaps are same in nature. Okay, so let's say if you want to break this bond, you will have a particular fixed temperature. Okay, because these bond and these bonds are same, or I would say gaps are same. Okay, so to break this gap, you will have a one fixed temperature, right? Okay, but in case of breaking this gap, you have one temperature, and in this gap, you will have another temperature, right? Because in both cases, the gaps are different. So breaking the high gap will be require low temperature, and small gap will require high temperature. So that's why in case of crystalline substance, the melting point is a fixed quantity. But in case of amorphous substances, the melting point has a range. Okay, it has a range. So this is the reason, due to the molecular shape irregularities, the molecular gap is different in case of amorphous compared to the crystalline substances. That's why to break the molecular gap or molecular gaps, okay, in case of amorphous, you require different temperatures, and that's why the melting point of any amorphous substances is a range always. Okay. This is a very important thing you should remember. Acha. Next point. So let's say another very important thing is cleavage. Cleavage. Let's take in this example again. Okay. Okay. This is a crystalline in nature, and this is a amorphous body you have. Now, this crystal, if you cut regularly in any way, let's say I'm cutting in this way. Okay. Here also I will cut in same way. So what you will have? You will have a very this surface is generated. Okay, the generated surface. Okay, the newly generated surface will be your clean and smooth. Okay, if I cut here, so what I will get? I will get this kind of surface here. And if I cut here, I will get this kind of surface here. But if I cut here, the shapes what I'm getting? Here is one shape, here is another. So two different kinds of surfaces you will observe in case of amorphous. Okay. So if you clip here, you will get a regular and plane surfaces. You will get in case of amorphous, you will get a irregular surfaces. Okay. This is okay. It's also an important point. Hmm? Okay. Now, if I talk about, so there are other also a few important points also like symmetry. In case of crystalline substances, you have symmetry, whereas in amorphous, you don't have any symmetry. Okay. Then let's say in the nature, this I will talk about the crystalline substances are known to have a perfect. They are known as perfect solids or the true solids. Okay. Whereas this amorphous, they have a slightly different name. I'm going to discuss this part now. Okay. Now let's say okay, I'm switching. Let's, okay. Let's talk about this amorphous body. Amorphous. What we can say about this thing? Hmm? Amorphous is an irregular shaped solid, right? Let's draw it. Let's draw irregular shaped body. If we cut from any region, it will have a different shapes and different place. True. Or if I melt, it will have a range of melting point. Now, can you tell me who has a range of melting point? Liquid molecule. Hmm? Okay. Now, what I said here, let's say my gap is high and here the molecular gap is low. So that's why the reason you have a range in temperature. Okay. So in both cases, the molecular gap is different. Okay. And that would result what? that results in different melting point. I would say, sorry, range in melting point. Okay. Acha. So as I said, who has range in melting point? Liquid. Hmm. Acha. So that's why when I say amorphous bodies, hmm, amorphous bodies, so they does not have melt in a fixed temperature. They melt in a ranging temperature. Okay. That's why these amorphous bodies are also have a name. Is called pseudo solids. They have a name pseudo solids. Okay, because they are solid, but they possess a solid character, but they also attain a liquid-like character. Okay. Now, if I tell you one big example, okay, acha, let me tell you one thing that why this amorphous means where this amorphous belongs. Okay, okay. Let's say you have this temperature range. Hmm, temperature range. Now, this region is your liquid region. If I say this is the liquid region, okay, and this is your solid region, okay. Now, this is increasing temperature. Now, let's say if I see this kind of region, this region which is near to liquid, this region particularly, this region is a near to liquid. Okay, this part is purely crystal. This part is purely crystal. But what the region I am talking about, this near to liquid, the amorphous solids exist in particular this region. Okay. Now, if I say that another example, if I give here, let's say if I say glass, okay, glass. Hmm. Glass, you have observed, I know many of you haven't observed, but it has been observed that if you go to the old buildings, you will find if you find a glass window or a door, okay, you will find this glass has a in the bottom it will have a swollen part. It will have a swollen part. Now why is it so? Because the glass is a amorphous solid, okay, or a pseudo solid, okay, and it has this amorphous solid has a tendency to flow liquid-like character, it has a tendency to flow. That's why all the glasses flows down and creates a small hump in the bottom of the window or the door, whatever. In the case of old buildings, okay, that's why they are known as to have a liquid-like character. Okay, if I say they have a liquid-like character, so let me use this term liquid. But there is there is but you cannot say directly to liquid because why? Because it has a solid like character also. So I cannot use the term solid liquid, right? So that's why you have to give this term because solid is a cooled substance. That's why the amorphous has a name which is known as super cooled liquid. They are known as super cooled liquids. Okay. So this is an important concept you need to understand. That is that the amorphous solids have a liquid-like character. Okay, because they can flow from higher region to the lower region. Okay, and due to that they can be termed as liquid, but also they have a solid-like character. Also they have. That's why you cannot say the name solid liquid and the solid usually exists in the cold region. That's why they are amorphous solids have a name which is a called super cool liquid. Hmm? Okay. Now this is I've so far I've talked about the amorphous. Now I will go to the directly go to the classification of the crystalline substances which is there. Okay, crystalline substances, crystalline substances. Now, before going into that, let me ask you one thing is that when I say crystalline substances, that means the substances are all obviously consist of atoms and molecules. Okay. Now, those molecules can be what? The molecules, the molecules can be polar, non-polar, right? Hydrogen bonded, right? They can be your metallic. They can be ionic, okay, and they can be covalent type, covalent type, okay. So this categories a molecule or an atom, molecule especially, molecule can atom. Molecule has this kind of this character. Okay. Now, so based on this things, hmm, these characters of a molecule, the the crystalline solids are classified. Okay. Now I will go to the one by one character. Okay, and I will discuss about briefly about the different parts, different classifications of the solids. Okay. Let's talk about these three parts first: polar, non-polar, and hydrogen bonded. These are usually observed in case of molecules. Okay, and metallic, it can be atoms or metallic single atoms and single atoms. Okay, and covalent type, it's a series of atoms. I'm not talking about this one. But these three characters are usually observed in case of the molecules. Okay, a collection of atoms, which is the molecules, right? Now that's why in crystalline substance, the first part is your molecular solids. Molecular solids. What we have here in molecular solid, the first case, number one. Okay, if you have a, let's say first non-polar. I'll have to talk about non-polar first. Non-polar molecules, you know what they can have? They will have a dispersion interaction between them. And due to the strong dispersion interaction or London force interaction, they will form the molecule. Like hydrogen, like helium, like argon, etc. So they will have a London dispersion force or dispersion interactions between them. Okay, and solid phase. So the and see that's the reason why hydrogen. This see if you think that these three are usually gaseous in nature, right? Okay. So but they are not solid. But then why I am classifying into the molecules? Because they can exist in solid state, depends on the temperature, right? But the solidifying them, it's very difficult because to generate the non-polarity, to generate the polarity in a non-polar substances is very difficult. Okay, until and unless you put up the systems. Okay, but instantaneous dipole comes due to their internal factors. Let's not discuss that. But this generally your when you generate a polarity in a non-polar species, that then you can this kind of species then this in this kind of species you can easily solidify. Okay, that's why and generation of that is very much difficult. Okay, that's why solidifying is hydrogen, helium, argon is very much difficult. And when you solidify them, they will have solid hydrogen, solid helium, solid argon. Then they can be termed as a molecular solids. Okay. Number two, when you say polar, it's a very big polar molecular solid. It's a very obvious because when I say polar molecules means like liquids, like HCl, I would say HCl, okay, HCl, sulfur dioxide. So they have a polarity, a direct, I would say, uh, mm, strong and permanent dipole in their system. So in HCl, you have yeah, due to the electronegativity difference between hydrogen and chloride, you will have a permanent dipole. In sulfur dioxide, also you have a permanent dipole. And due to this permanent dipole in interaction, which is stronger than obviously the non-polar dipole interactions, okay, they can be solidified. And when they solidify, they also one type of molecular solid which has a polar character. Okay. Acha. Number three. Okay. What happens in terms of in water? Ice. Ice. In case of ice, what you have, this is the molecule, water molecule, and here this water molecule is hydrogen bonded with the another water molecule. So this is basically a oxygen and hydrogen bonding interaction. Okay. Similarly, you can find in case of urea, nitrogen hydrogen bonding interactions. In case of hydrogen fluoride also, you can have hydrogen and fluorine, okay, interactions, hydrogen bonding interaction. Now, due to these hydrogen bonding interactions, in case of ice, the in ice, if you see, they are perfectly hydrogen. They have perfectly hydrogen bonded condition in case of ice. Okay, and that is a very important and very means the live example of the molecular solids which has hydrogen bonding property. Hmm? Okay, so these are the molecular solids. Okay, these three categories: it's non-polar, polar, and hydrogen bonding. Okay, now let's move into next category, which is the metallic. So metallic solids. Okay. Now what we have in case of the metallic solid, it's very much evident that one metal. Okay, if I say D metal, okay, you maybe you don't know about the details about the D metal chemistry. The D metal, it is charged, maybe charged or not charged. Okay, but it has excess, very, I would say, sea of electrons. Okay, and that sea of electrons in case of, let's say, iron, in case of copper, in case of silver, okay, in case of silver, that sea of electron, they have a sea of electron, and that sea of electron can conduct electricity, okay, in their crystalline, I would say, in solid crystalline state, okay, and that sea of electron can conduct electricity, and also they can show in presence of electric field and magnetic field, they show different properties. You will learn this in your inorganic chemistry in class 12 basis, okay. And like examples I said, iron, copper, silver, okay. So what is the more major point it has? It has positive charge maybe, but it has also a sea of electrons, okay, and that sea of electrons makes it electrically, your means electrically conductive, okay. Acha. Next, so metallic is done. Now what? Ionic. It's a very important ionic solids. Ionic solid. What happens in case of ionic solid like sodium chloride? Let me directly give you an example. Sodium chloride. Okay. Sodium chloride, zinc oxide. Okay. Zinc oxide, zinc sulfide. Okay. They have an Now, in these cases, what happens? You have individual ions, sodium ion, chloride ion, zinc ion, sulfide ion. These ions will have a strong electrostatic interactions between them, and that strong electrostatic interaction will hold the ion together, and they will form a crystalline solid substance. Number one. Number two, when I'm saying that they will hold together by strong electrostatic interaction, that itself suggests that they will have a high boiling point as well as high melting point. But what about the electrical conductance? Electrical conductance in case of the solids, they will not conduct any electricity. Why? Because the molecules are rigid. Okay, the atoms are in the ions are in the rigid position. They are not moving. Okay, but if they are in molten state or in aqueous state, what will happen? Now they can conduct the electricity. Okay, so that is the important property of the ionic solids. Okay, and another property is, okay, another is, so ionic is done. Now covalent type. Okay, covalent type. Now covalent type, I would say here, it's the proper word will be covalent network. Network will be the actual word, because these covalent molecules, let me give you an example, it will be more clear. Like graphite, then your diamond. Okay, these are basically polymeric substances. Okay, and polymeric substances are homomers basically. So graphite and diamond all are carbon allotropes. Okay, now these allotropes, these carbon allotropes, the graphite and diamond, they form a huge network by covalent bond formation, by the formation of the covalent bond. They can form a huge network. Okay, and that huge network makes your element, I would say the system, very spin, they get the solid like character. Okay, and that solid like character, in case of usually the covalent network, they are they does not conduct any electricity, but there is an anomaly. What is the anomaly? In diamond, they does not conduct the electricity, but in case of graphite, they conduct the electricity. Let me tell you why. Okay. Because, okay, before that, you should know one thing. In case of diamond, the carbons the carbons are sp3 carbons. Okay, but in case of graphite, what you will have, you have a hexagonal unit like this way. Okay, hexagonal unit, and these each carbons are sp2 hybridized carbon. Right, so this is one layer, this is one layer like character. Since it is sp2 hybridized carbon, so you have a delocalized electron, but here that you have no. Now, in case of graphite, due to the presence of this delocalized electron, this electron can move from one layer to another layer. Okay, one layer to another layer. If you conduct the, if you give the layer, whatever the potential difference. Okay, and this graphite, this is the reason why graphite can conduct electricity, whereas since diamond doesn't have any free electron, as each carbon has hybridization state sp3, it cannot conduct. Okay, so that's all for now. So far what we have discussed is that what introduction I have introduced the solid, and the difference between the two states is the crystalline solid and the amorphous solid. Few details about the amorphous solids, about why it is called pseudosolids and why it is called super cool liquids. I have discussed. Okay. Other than the different classification of the crystalline solid, which is based on the polar, non-polar, hydrogen, metallic, ionic, and covalent type systems, and molecular solids, metallic solids, ionic solids, with all the examples, and the covalent network types. The example is graphite and diamond, and in between them, it is the covalent networks are known to is a non-conductor of the electricity, but the graphite is one of the exception. Now, why it is exception? Because all carbons are sp2 hybridized, and it has a delocalized electrons, free electrons, and that electron can conduct the electricity. Okay, so thank you, and in the next lecture, I will continue after this.